Azure offers a variety of compute options to meet different needs. Understanding these options is crucial for optimizing performance, cost, and scalability. This presentation will delve into three primary compute types: containers, virtual machines, VMs, and functions. Each has unique characteristics and use cases, making them suitable for different scenarios. By the end of this presentation, you'll have a comprehensive understanding of these compute types and how to leverage them effectively in your Azure environment. Virtual machines, VMs, are emulations of physical computers. They run an operating system and applications just like a physical computer. In Azure, VMs provide the flexibility to configure the environment exactly as needed. You can choose the operating system, install software, and configure settings. VMs are ideal for applications that require full control over the operating system, custom software configurations, or legacy applications that cannot be easily containerized or converted to serverless functions. VMs offer several advantages, including full control over the operating system and software stack, the ability to run complex applications, and support for a wide range of operating systems and software. They are also highly customizable, allowing you to allocate resources such as CPU, memory, and storage based on your needs. Additionally, VMs can be easily scaled up or down to meet changing demands, making them a flexible option for many workloads. Despite their advantages, VMs come with some challenges. They can be resource-intensive, requiring significant CPU, memory, and storage. This can lead to higher costs, especially for large-scale deployments. VMs also require ongoing maintenance, including operating system updates, security patches, and software upgrades. Additionally, VMs can take longer to provision and start compared to containers and functions, which can impact agility and responsiveness. Containers are lightweight, portable units that package an application and its dependencies together. Unlike VMs, containers share the host operating system's kernel, making them more efficient and faster to start. In Azure, containers can be managed using services like Azure Kubernetes Service AKS or Azure Container Instances ACI. Containers are ideal for microservices architectures, continuous integration, continuous deployment, CI/CD pipelines, and scenarios where rapid scaling and high density are required. Containers offer several benefits, including faster startup times, efficient resource utilization, and portability across different environments. They enable consistent development, testing, and production environments, reducing the risk of discrepancies. Containers also support microservices architectures, allowing you to break down applications into smaller, manageable components. This enhances scalability, maintainability, and agility. Additionally, containers can be easily orchestrated using tools like Kubernetes, simplifying management and scaling. While containers provide many advantages, they also come with challenges. Managing containerized applications can be complex, especially at scale. Orchestration tools like Kubernetes require a steep learning curve and can be difficult to configure and maintain. Security is another concern, as containers share the host OS kernel, potentially exposing vulnerabilities. Additionally, not all applications are suitable for containerization, particularly those with heavy dependencies on the underlying hardware or operating system. Functions, also known as serverless computing, allow you to run code without provisioning or managing servers. In Azure, this is provided by Azure Functions. Functions are event-driven, meaning they execute in response to triggers such as HTTP requests, database changes, or message queues. They are ideal for scenarios where you need to execute small pieces of code in response to events, such as data processing, real-time stream processing, or back-end services for mobile applications. Functions offer several benefits, including automatic scaling, cost efficiency, and simplified management. Since you only pay for the compute resources used during execution, functions can be more cost-effective than VMs or containers for certain workloads. They also automatically scale to handle varying loads, eliminating the need for manual intervention. Functions simplify development and deployment, allowing you to focus on writing code rather than managing infrastructure. This accelerates time to market and enhances agility. Despite their benefits, functions have limitations. They are typically stateless, meaning they do not retain data between executions. This can complicate scenarios requiring persistent state or long-running processes. Functions also have execution time limits, which may not be suitable for all workloads. Additionally, debugging and monitoring serverless applications can be challenging, as traditional tools may not provide the necessary visibility. Finally, vendor lock-in can be a concern, as serverless architectures are often tightly coupled with specific cloud providers. When choosing between VMs, containers, and functions, consider factors such as control, scalability, cost, and complexity. VMs offer the highest level of control and are suitable for legacy applications and complex workloads. Containers provide a balance of control and efficiency, ideal for microservices and CI/CD pipelines. Functions offer the greatest simplicity and cost efficiency for event-driven workloads. Each compute type has its strengths and weaknesses, and the best choice depends on your specific requirements and constraints. VMs are well suited for a variety of use cases, including running legacy applications that cannot be easily containerized, hosting complex applications requiring full control over the operating system, and supporting development and testing environments that need to mimic production settings. VMs are also ideal for applications with specific hardware or software requirements, such as specialized databases or enterprise software. Additionally, VMs can be used for disaster recovery and backup solutions, providing a reliable and flexible infrastructure. Containers are ideal for modern, cloud-native applications that follow a microservices architecture. They are well suited for CI/CD pipelines, enabling rapid development, testing, and deployment. Containers are also perfect for applications requiring high scalability and density, such as web applications, APIs, and real-time data processing. Additionally, containers can be used for hybrid and multi-cloud deployments, providing portability and consistency across different environments. They are also beneficial for development environments, allowing developers to work in isolated, consistent settings. Functions are best suited for event-driven workloads, such as processing data streams, handling HTTP requests, or responding to changes in a database. They are ideal for building back-end services for mobile and web applications, automating workflows, and integrating with other services through triggers and bindings. Functions are also useful for scheduled tasks, such as running periodic jobs or maintenance scripts. Their ability to scale automatically and cost-effectively makes them a great choice for unpredictable or spiky workloads. In hybrid and multi-cloud scenarios, you may need to leverage a combination of VMs, containers, and functions. For example, you might use VMs for legacy applications, containers for new microservices, and functions for event-driven tasks. Azure provides tools and services to manage these diverse environments, such as Azure Arc for hybrid management and Azure Kubernetes Service, AKS, for multi-cloud container orchestration. By combining different compute types, you can optimize performance, cost, and flexibility across your entire infrastructure. Security is a critical aspect of any compute type. For VMs, ensure that operating systems and applications are regularly updated and patched. Use network security groups and firewalls to control access. For containers, implement security best practices such as using trusted images, scanning for vulnerabilities, and isolating containers. For functions, focus on securing the code and managing access through identity and access management (IAM) policies. Azure provides various security tools and services, such as Azure Security Center, to help you secure your compute resources. Cost management is essential when using Azure compute resources. VMs can be cost-effective for predictable, long-running workloads, especially when using reserved instances. Containers offer efficient resource utilization, but costs can add up with large-scale deployments. Functions provide a pay-as-you-go model, making them cost-effective for intermittent workloads. Use Azure Cost Management and Billing to monitor and optimize your spending. Implement cost-saving strategies such as auto-scaling, right-sizing resources, and using cost alerts to stay within budget. Optimizing performance involves selecting the right compute type and configuring it appropriately. For VMs, choose the right size and type based on your workload requirements. Use features like Azure VM Scale Sets for automatic scaling. For containers, optimize resource allocation and use orchestration tools like Kubernetes to manage scaling and availability. For functions, ensure that your code is efficient and leverages Azure Functions scaling capabilities. Monitor performance using Azure Monitor and Application Insights to identify and address bottlenecks. The landscape of compute is continually evolving. Emerging trends include the increasing adoption of serverless architectures, the rise of edge computing, and advancements in container orchestration. Serverless computing is becoming more sophisticated, with new features and capabilities being added regularly. Edge computing is gaining traction, enabling low-latency processing closer to the data source. Container orchestration tools are becoming more user-friendly and integrated with other cloud services. Staying informed about these trends will help you make strategic decisions for your Azure environment. Choosing the right compute type in Azure depends on your specific needs and constraints. VMs offer maximum control and are suitable for complex, legacy applications. Containers provide a balance of efficiency and control, ideal for modern, cloud-native applications. Functions offer simplicity and cost efficiency for event-driven workloads. Consider factors such as control, scalability, cost, and complexity when making your decision. Leverage Azure's tools and services to manage and optimize your compute resources effectively. Stay informed about emerging trends to future-proof your infrastructure.